Good. Time series with Microsoft SQL Server. This is my topic for the next 60 minutes. The good thing here is it won't be boring because I have lots of demos here for you to show you how this will work. But before we go with this, we first of all need to understand what time series in SQL Server mean in general. Let me show you one website where I show you a very interesting thing where I can see how time series work. So since 2 months, I'm a proud owner of a photovoltaic system. I love it, especially when I see how much of the power is going back to the vendor. And this one here is from my system. What you see here is that how much power I produce, how much get used by the house, how much get loaded into the battery, blah, blah, blah. And the cool thing with this is this one. Whenever I click on one of the evaluation forms, it goes rather quick that I get immediately data back. So whenever I select, for example, here, one date range, it immediately comes back. And the question is, how does it work so fast? Because this vendor here of this hardware, he has not only my software or my hardware here, he has hundreds of thousands implemented in Germany. So the question is, how does this work? And this system is connected to the internet, and periodically the machine is sending data to the vendor over the air, over the cloud, stores it, and I can then evaluate it. And it's all based on time. Everything is based on time. I want to see how much did I produce for the last 15 minutes, last 30 minutes, and so on and so on. And there are a few challenges in this. And this is what I want to show you. Before we start, a big, big thank you to the vendor, to the sponsors of this event. You all know that without these sponsors, these kind of events won't be working pretty good. So thank you. I think they will be very happy about it. This is my agenda for today. What are time series data? How do they work? What makes time series special from other databases? Because you will see there are vendors who have database systems optimized for this kind of work. What relational database management systems are available for time series, and what techniques can be used within Microsoft SQL Server? Because, hey, come on, we are all Microsofties. I want to see how we can handle this in Microsoft SQL Server, because that's my preferred database system. So what can Microsoft do? What features does Microsoft have? And especially, what features or what functions does SQL Server provide since SQL 2022? Because there was a huge improvement in it. And last but not least, because I think you all are sitting here because you want to see a little show, I have queries to produce the data and want to show you some tricks before 2022 and with 2022. So what are time series? Well, that's, I think, basically is a very, very simple to understand. Time series data is a set of values organized in the order in which they occur and arrive for processing. And believe it or not, but we all are dealing every single day with these kind of data, especially when it comes to modern cars. They are sending permanently data to the vendors. And these are time series. Time series are typically written once. So the data gets normally only inserted into the table and never touched again. Then it comes to the evaluation. It's very rarely that they get updated. I've never seen it. Example, skyscraper in Frankfurt. And when you see, there is one skyscraper in Germany, quite interesting. They don't have an air conditioning system. That's really cool. What they have, every 30 floors, they have, let's say, trees, trees. And depending on the temperature, on the humidity, they opened windows in these kind of floors. And with this opening, closing, they are controlling the air condition in the complete skyscraper. Really interesting. And that is based on time series. Typical example of time series, you all know, stock prices. Yeah, they never get changed, hopefully not. Telemetry data from sensors and performance metrics. That's what we are dealing with when we are monitoring our systems. Time series data is often used for historical comparison, anomaly detection and alerting, predictive analytics. Maybe some of you are here working with RE or KIs, reporting, where time is a meaningful access for viewing or analyzing data. My database I have has around 30 million rows in it. I wanted to make it a little bit larger, but then I saw, I only have 60 minutes here. Doesn't make sense. Good. What makes time series special from another database? The one and only, the most important thing here is the high number of simultaneous transactions. Think about this. I showed you my photovoltaic thing, and you know, I'm not the only customer. They have hundreds of thousands, and every single minute they are pushing millions of data into the database. So that must be very, very, very quick. And the good thing is that you can handle this with Microsoft SQL Server, with the RDBMS system. I know there are special database systems handling that, but you can deal with this with Microsoft SQL Server in the same way. Who of you knows about partitioning? Partitioning is a architecture inside your database where you can spread all the workload over multiple files. That makes it incredibly fast. Grouping of data volumes by time intervals, mainly query of current values. That is the key point here. So the main queries which are running again a time series are normally between, let's say, last 60 minutes or let's say the last 24 hours, basically. What database systems are available for time series? You all know a few of them, I think. Azure SQL Database. You're wondering, say, what? Yeah, since SQL 2022, because we have special functions now. We're dealing with this. Managed instances, on-prem. The good thing with Azure SQL DB and managed instances is they are platform as a service. And that's something what I really like. They support the relational model. And then there is one very, very interesting database system. Who of you know Postgres? A few, huh? Oh, okay, a little bit more. But the good thing is, Postgres has a so-called add-on or an extension. It's called Timescale. And I was testing it. I was playing around with a good friend of mine in Germany. And unfortunately, I have to say, SQL Server lost the battle. They are incredibly fast. Really, they are specially designed for time series. Azure Storage Accounts. This is scalable, but there is no optimization for queries. Azure Data Explorer, Coast Incentive. Influx is a dedicated database management system designed for time series, and OpenTSB, same as Influx. Only problem with these both is that they are not supported as platform as a service, so you need to run it by yourself. That's it. Techniques for time series in SQL Server. So when it comes to the point that you have to design your database for time series, you need to think about some architectural designs. Relational tables, you can, because we are dealing with really lots of data, use index compression to store your data in a compressed form on the storage. The good thing with this is that the huge amount of data get really efficiently stored and compressed when you use page compression. But there is a tiny drawback. It costs you CPU. Because what does SQL Server have to do when it comes to the evaluation of the data? It needs to decompress it when it comes into memory. But therefore, we have another feature, column store indexes. Who of you is aware of column store index? Who know column store indexes? And I think most of you are using column store indexes when it comes to data warehouses, right? Because of this incredible compression. Excuse me. I show you one query where a column store helps to improve my query dramatically. Partitioning is for writing very good. Column store has a big problem with inserts. The reason is very simple. Column store techniques does mean that the data are highly compressed, really highly compressed. But what is with new data? When SQL Server will compress them immediately, putting them into row groups, that is way too time-consuming and CPU-consuming. So therefore, SQL Server, no problem. It's for free. Come in. Yeah. So Column store indexes is working with delta stores, and delta stores can lead to tremendous problems. Because what is delta store doing? When we have a column store index and we are pushing data into it, row by row by row by row, SQL Server cannot compress these data. The reason is very simple, it's too time consuming. So what SQL Server then will do is we are creating, let's call it a shadow table, which has exactly the same structure as the table itself. It's behind the scene, but this one is not a column store table, it's a row store table. That means it's a normal heap or clustered index. And there we can push the data into. So what will happen then? Every 2 minutes, there is a little helper going around and say, hey, you delta store, do you have at least 104,000 rows in it? I say, yes. And then the helper is compressing it and pushing it as a row group into the column store. But what can be the problem? I had it with one customer in Germany. They had so much delta stores open that the tuple mover, this is the name of the helper, didn't come on with his work because they were way too fast creating new delta stores. And that was growing and growing and growing. High compression is the good thing here with column stores. Basically, for time series, I would not recommend column store when it comes to inserting data. Or if you want to do that because you need the space, you can do that with a little trick. What I'm doing then is I create a so-called in-memory table. I'm pushing all the data into the in-memory table. It's lock-free. It's incredibly fast. And when it comes to a number of rows I have, which immediately put the data into a compressed row group, then I'm pushing the data into the column store. That is one technique what you can do. And another very interesting thing, what not very much people have on the focus, but that is something where you can really speed up your queries, is index views. Who knows about index views? You see, not so much people, huh? Yeah, but it's very interesting, but one problem with index views is the requirements when it comes to index views. Nightmare, nightmare. However, time series in SQL Server is used normally for historical comparison, anomaly detection and alerting, predictive analysis, reporting, where time is a meaningful access for viewing and analyzing data. The time series capabilities in SQL Server were introduced in Azure SQL Edge the first time, Microsoft's version of SQL Server for Internet of Things, because when we are talking about time series, I would say 99% is Internet of Things, such as data streaming, time series, built-in machine learning, and graph features. And since SQL 2022, thank you, Microsoft, we have a few very interesting functions which makes it very, very easy for us to generate time queries. For example, generate series. Maybe you know the line number function from Itzik Ben-Gan with the trick with the cross-apply, with the recursive query that we get hundreds of millions of numbers. Now it's implemented in SQL Server with the function generate series. The most important thing for me, the date bucket function. The date bucket function creates, as the name say, buckets for an interval of times. For example, every 15 minutes, every 30 minutes, every 60 minutes, and so on. And this one will automatically create these kind of buckets where we could put the data in. Date trunk, first and last value. First and last value is not new. That was earlier, but there is one interesting news. Common solutions. Now that it was with PowerPoint, we now come to the problems, what can we do with the data? Let's say we have the data in our system, and now we want to run queries with this. And how did we do this before it was coming to SQL 22? How did you create buckets, date buckets? Any idea? What would you do? Window function, super, yeah. Window function is one thing, but let's say you want to have a range of, let's say, a 15-minute table. Any other technique, that's a good thing, yeah. I don't have it in my demo, that's the reason why don't want to get more in detail with this. But I think you all are using CTEs. Common table expressions are very helpful for this, because recursive CTEs. What will I do? I create the so-called anchor. Hey. I create the anchor, and then I just call it recursive step by step for every single bucket. And then I have my list, what I need later on for the queries. And let me show you how this will work. Oh, old man is sitting down. Yeah, I love it. Every year it's more a pleasure to sit down. Let me show you my table. I have prepared something here for you. By the way, all the scripts, you can download the scripts, you can download the database where I'm doing all the playground, everything. Yeah? So my database is called DemoDB, and I have just only one table here, and this table is called weather data. So in this table, we have around 30 million rows from 10 cities, and the data are coming in with a 1-minute interval permanently. So within this table, these are my columns, the time and the city name. This is my primary key. I come later on to this. And what I'm running a query almost all the time is against temperature in Celsius. And here are my indexes. I just only have one on it. One key point when it comes to time series is that you should not overload your table with indexes. I think you all know what happens. As more indexes you have, as slower is your insert. Makes sense, yeah? So then I have created from the same data, it's a one-to-one, it's only for comparison, I have created a partitioned table out of it that I will see whether it's working better with partition tables. And what I have done is I've created the same table in column store so that we can compare both to each other, okay? Whenever you have a question, just raise your hand and I'm happy to answer it when it comes to the demos. Can you read? Can everybody read this? Super. You are not so old as I am, because I have no problem to read it, and you can read it from the last row. Perfect. Here comes my first query. This is the easiest kind of query. Let me do it a little bit larger, 120%. You will see this will be better. Good. So here is a typical query, very simple, very easy. I want to have for every single city per year the average temperature. The key point here is keep the following in mind. I have an index on the city and then on the date. City first, then the time. So when it comes to the aggregation, you see it here, the aggregation by a transformation is a big problem for SQL Server. Why? Let me show you first of all the query with execution plan, and here it comes. It takes a little bit because 30 million rows need to be selected. Here it is. It was taking 4 seconds. Looks perfect. When I think about 30 million rows and they would say, wow, that's good, let's implement it. And now it's live on the website. And suddenly your server is going down. You see, suddenly you have tremendous memory pressure on your server. And the reason for that is this one here. Let's go into details. So the first thing I think is very, very clear. What SQL Server is doing, because we are running a query against all our data, is very simple. We need to scan our clustered index. Then it comes to the compute scalar. The compute scalar is a technique where we do the aggregation or the transformation because we want to extract the year. Simple. And now comes the problem. Hash match aggregation. What is a hash match aggregation? A hash match aggregation does mean that SQL Server gets data unsorted. But what we need to have is we need to have an aggregation by year. By the way, with the windowing function, we would have exactly the same problem. Data are coming unsorted. So SQL Server must sort the data internally, aggregate them, and pushing them to the next operator, which is the compute scalar. Let's see what this means. By the way, anybody here who does not know the difference between a stop operator and a flow operator? Anybody who has never heard about that? Okay. A stop operator in a relational operator list means that SQL Server needs to wait till all the data has been operated inside the operator. In total, it does mean that SQL Server, first of all, needs to allocate memory to get all these data coming from here, the 28 million rows, and process them. When this is done, then SQL Server is pushing the output, the last 60 rows, you see this here, 60 rows, is pushing them to the next operator. Unfortunately, the next operator in this time, that's easy, it's this compute scalar. The compute scalar, what is it doing? It's calculating the average, but the average from the rest of the data. And then it comes to another sort operator, and that is because my query is running with an order by. Here. So far, I think it's clear, but have a look to this. I enlarged it. Have a look to the memory grant. We are consuming 78 megabytes of memory for this query. And this 78 megabytes is because of the hash match operator and the sort operation. Both operators are stop operators. So SQL Server must wait, and therefore, when we have these kind of operators, you will find it always in execution plans when you see hash match operators, hash aggregations, sort operators, table spools, all these kind of operators are stop operators. So what SQL Server then must do is we have to ask for memory before we execute the query. What do you think what will happen if SQL Server will not get the required memory for the query? It will wait. Exactly. And that will happen here. When you say, oh, I need 78 megabytes and you don't get it, yeah, then SQL Server says, well, I will wait for it. And you will see that in wait_stat with the semaphore wait_stat. That is a typical indicator of it. Okay, let's see whether we can make it in a little better way. What I'm doing here now is I want to create with a cross supply a pre-calculation of the transformation, and I want to see whether this will work. So clearly the point is it looks different, but let's see how SQL Server will deal with this. What I'm doing now is with the cross supply, I put the time into the cross supply function, then I transform it to a year and give it out. Maybe this will help. Abracadabra. And we wait, and we wait, and we wait. Ah, here the data are. 4 seconds. Let's see what SQL Server did. Exactly the same. So we cannot cheat the query optimizer. The query optimizer saw, hey, come on, it's a transformation. It's the same as when we put the output directly into the select statement. So there is no improvement with this. And you see that the memory grant is exactly the same. No optimization. Keep that, please, in mind when it comes to date bucket. If no, excuse me, if no pre-ordering is available, then we must have the hash aggregation. Do you know any technique how we could do a pre-ordering of these values? Did anybody of you heard about the situation that you create a indexed column, a column where the function in it, and then you put an index on it? Oracle, Postgres, they have so fantastic feature. It's called functional index. Anybody heard about that? I wish that Microsoft will have it, but Microsoft said, nah, you don't need it. I said, why? They say, yeah, do it very easy. Create a view with all the columns you want to have. Inside the view, create a column based on this function here. Put an index on the columns. That's it. Then you have a pre-ordered situation. But what does it mean for us? If we create an index view with the calculated column, we have the same amount of data in an index. So, and I don't want to have this. So this is something what we won't achieve here. Microsoft listened to that. Microsoft said, let's think about SQL 2022. Maybe we find some new interesting features. And they got one, it's the date bucket function. I show it later on to you. So when pre-ordering cannot be achieved, then SQL Server uses the hash aggregation. There's a question? Yes. The question was, where can you download the material? 1 second, please. Make a screenshot now. Yeah. Oh, yeah, I understand the question. The question is, what is better? Is it the datetime data type or the datetime2 data type? Question is very easy. Datetime is a SQL Server data type, but datetime2 is an unseed data type. So I would always prefer datetime2 to do it. But you can handle it with both, by the way. Question answered? Great. Let's go back to work. Good. Bing, 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 bing. So. Okay. We are now here at that point. The problem is the hash aggregation. The hash aggregation is because we have no pre-ordered data. And now see what I'm doing here. I force SQL Server now to order the groupings. But see what happens now. I run it with the live execution plan. Execute. And see what happens here. Enlarge this. You see that we do not have a hash aggregation now. But what we have is a sort operation. It's finished. Wow, but 10 seconds. It was more than double of the time. But that's not all. We are here with Nelly van Zyl. If you call now, I don't give you just only one of the pieces. No, I give you 2 of them. And delivery is free. Look to this. Wow. Is that cool? The reason is very simple. The hash aggregation does not have such a big memory footprint as the sort operation has. There is one big problem with the sort operator. The sort operator cannot scalar. So that means as more you have, as more time and resources it's consuming. And it's a linear. It's not something like, we start very smooth and then we go immediately up. No, it's linear. As more you have, as more resources gets allocated. Not the best technique. You see, with 2015 or 2019, we had a few problems with the aggregation part. And Microsoft listened to that. But before we come to 2022, let's see how we were solving these kind of queries. That looks easy. Give me, for the last 15 minutes, that is a typical thing. For the last 15 minutes, the temperatures for New York City. That's exactly the same as in my website here. It's closed, okay. Where I said, okay, give me, Sammy, how much power I have produced in the last 5 minutes. That's exactly the same. So think about this. This is my photovoltaic thing, and this is the last measure. And I want to go back 15 minutes so that I see the last 15 minutes. The index is on the city name and then on the time. The reason is very simple here. Normally, what you would do is, when we are dealing with queries against time, it's more a range than a dedicated timestamp. You say from to, like this. So that is the reason why I've decided to put a index on the city name first, where we have the equal predicate. That means we go immediately to the city, and then we can collect inside the city for the time. Let's see how this will work. So give me the last 15 minutes. I think that goes very quick. Yes, it is. Very simple. Let me explain in short words what SQL Server is doing. Here is an index seek. The index seek is going on the city name. Very simple. And that comes from the max. Give me the last entry. Because you see that here on the top operator, say give me the first, we go the index from the back and stop after the first value, then you have the max. Here is an aggregation of it. So now we have it, and then we can go and look into the clustered index for the dedicated rows. Very simple, very easy. But this is not the only way how you can handle this. It might be that you would work, that you prefer to work with subqueries. No worries, why not? Do that. But to be honest, I love to work with CTEs in that way, because CTEs give me the opportunity to create my solution step by step by step by step. For me, it's a matter of what you like. Okay, see how you can deal with that exactly the same way. Here, I say, give me the max time, and then use that with an inner join in the clause in the join clause, where I say the time must be greater or equal to the max. That is exactly the same. So whether you're using subqueries or using CTEs, it's not a performance issue. It's only something what you like to prefer. Now it comes to a bigger problem. And this is a typical query, what you're running against time series. Let's say we want to have for 1 hour in an interval of 15 minutes for Austin, the average temperature. So there was one solution named pretty cool windowing functions. Why not? That will work. But here, what I want to see now is I want to have 4 rows for every full 15 minutes, the average temperature. When I think about this, the first thing what came into or comes into my mind is I need to have 4 time buckets. And not only a starting date, but I need a time range from to. Always. Because I need to find data which are in between the borders. And how you can do this is with this one. It looks complicated, but let me show you how it works. Select star from bucket list. Just only to show you the result. Who of you does not know the technique of recursive CTEs? No idea about that? Super. Okay, what I'm doing here is I start with the anchor. So I say, give me the start time with it, which is the 27th of April, midnight. And then I'm using the function date at. I go in 15-minute intervals from the start date. So that means that the end date is this date plus 15 minutes. Now I have a single row, and what I'm doing then is I'm recalling the result of the anchor again and again and again and again. And that is a recursive CTE. Let me show you the result of it, what comes out of this here, before it comes to the query. What you see now here is, in the results, exactly the time range. You see here the starting point, end point, starting point, end point, starting and so on and so on. These are my results. The most important thing is when it comes to recursive queries that... Excuse me? 1, 2, 3, yeah, let me see, 130. Yeah, end date is 1. Sorry, yeah. So the question is, why did we have 6 here? The question is, when this condition when it comes to this condition, that means we go for one more recursion, because this has fulfilled, and that means, okay, we must go one more turn. The filtering must be then in the original select when we filter the data later on. It goes always once more, because the condition, the last condition, when it fits, this means go one more turn. That is the reason here. So let me show you how we can now deal with the result. So now we get our time ranges, and the only thing what we do is with this bucket list here, we put this in an inner join with our original data, and this is my condition for the join. Say the time must be between these two borders. And then I come here, here's the filtering, by the way, that you will see only for later on. So I do it with option recompile for one simple reason. The reason for that is that I want to use the histogram of the statistics, otherwise it won't do. This is the execution plan, looks very simple. Here's the result. You can see, you can see here, one moment, I switched this off, this is too boring. So here we are. And that was incredibly fast, but that was because of the indexing. The key point is that I have created the time range, and that was the challenge here. I must have a line or a temporary table which holds my limits, which I need to compare against the data. Here is another one. If you want to have the average temperature for all cities, they all must be part of the CTE. Otherwise, your query might not come back. Here is my start and my end date. Here is again my bucket list, and you see that I here have the select distinct city name from my row-based table with 30 million rows. Oh la la. And when you see what happens here, you will say, oh my goodness, what's going on here? The query will run and run and run and run. And the reason is this one here. So in the meantime, I can dance for you, but I'm not a good dancer. You see that SQL Server, it's done now, but SQL Server was going through all rows. Reason is very simple. The row-based index is not the best choice here because we need to scan it. The city name is the very first part of the index. City name first, then the time range. And if a distinct is nothing else but an aggregation per each city. So SQL Server is scanning all the 30 million rows. Here we come back with our 10 rows. These are our 10 cities. And then, and then we could go with the cross-apply operator. So that is a very, very slow technique. But what we can do is the following. Here is, by the way, the output. Oh, and what I see here is something. This is, okay, yeah. I was cheating you. Pika with a, no, I'm not cheating you. Okay, perfect. So the problem here is that we have a tremendous amount of data, what we need to cover here. And what we can do is, in this case, maybe a column store index may help. But see this here. You see here that I'm using a column store. It's the same data, exactly, one-to-one the same data. I'm using the column store data for my CTE to get my 10 companies. And you believe it or not, that will go very, very quick. Because now we participate, because we need a scan. I think you all are clear that we need a scan on the object. But the column store is highly compressed. And that makes it incredibly fast. But then I'm using it here the same way. for the calculation. And that is a killer. I go for this. Go for it. And you will see here we have our 10 data. Wow, that was really quick. But see what SQL Server now must do. We are now going through the column store index again and again and again and again, because for every single city, we need to have the date range. We need to query against the date range. And the column store index is not ordered. So that means SQL Server we can have luck that we can finish it by segment elimination, but that is, there is no guarantee for this. But maybe a mix of it. Let's say we want to have from the column store index only the city names, but then we are going back to the row-based index and run the query against the row-based index. See this? You see, it's running again. Huh? Trust me, it will not come back. I was waiting. In the meantime, I was watching a TV and it was never coming back. But now, whoops, done. In less than or nearby a second. The reason for that is here that SQL Server now was using the column store index to get the 10 cities. Great. But afterwards, we could use the row-based index, which is more granular than the column store index, because here we could use an index seek on it. Now, how can you achieve that when you see that you permanently have queries exactly that way? Can be. Especially when it comes to web interfaces where the users want to permanently see, like me. Yeah. Since I have my photovoltaic, I only want to see how much money did I earn? How much money did I earn? Yeah. So, and then hundreds of thousands of people are doing exactly the same. And when you see that these kind of queries are coming permanently in, try it with an indexed view. An indexed view is a very simple thing, but unfortunately lots of requirements. I don't want to go too much into detail about the requirements, but see this, what I'm doing here is. By the way, I'm now using the new function here, the date bucket function. So I create a view for an interval of 5 minutes, 15 minutes, 30 minutes. The key point then is that I create an index on it. What is the absolutely super hit here with this? Think about this. Here we have an aggregation. And the aggregation does mean that we do not contain all 30 million rows, but only the results. When it comes to 30 minutes intervals, that means that we have only 1/30 of the amount of data, around about 1 million rows, or maybe 100,000 rows. And that makes it horrible fast. When I run this query, go, done. And look to the I/O. That you will be, one moment, that was my fault, sorry. This is live, color, happiness, hey, go. Again. So for 1 hour, for the 15 minutes, go for it. Seems to be not working. See the execution plan. And you see that SQL Server is using the primary key of the table. The reason is here that SQL Server, I do not know why actually, I'm figuring out, is that it will not that it will expand the query. So that means the original query, what is inside the query. With no expand, which is normally an enterprise default feature, it works like a charm. And go. Finished. You can see this here from the I/O. It goes through all of it, but then SQL Server is using my clustered index on the view. So far, so good. What gives SQL 22 for us to improve the queries? First, and most important, the date bucket. The date bucket is a game changer here, and because you remember that we have the hash aggregation when it comes to transformation of non-indexed columns. And the date bucket function, that will consider this. What is the date bucket function doing? The date bucket function, as the name say, bucket, we are building buckets. And what we do here is we can use, are we finished? No, 10 more minutes, right? Yeah, okay, good. Makes me nervous, good. The date bucket function is generating a date, for example, here for the week, for example, saying this is the interval for how many we want to skip, one by one, from the actual date. The origin date is an optional parameter, which means from what date we want to start for the calculation. If you don't give this parameter, SQL Server will always start from the 1st of January 1900, which is a Monday, midnight. Okay? So let's see the result here. And what the result of the date bucket will always be a date or a date time. Depends on the value for the given date, what you want to transform. Here you can see this, here, the 10th of April 23, and this is a date time format. See how this will work here when I run this query. I want to have for the 1st of January 21 to the 3rd of January the month when it was. So keep in mind that I'm going from January, it's the January 1st to January 3rd. Come on, what is this? What? Ah, sorry, yeah. I need to go in my database. So here you see the time, and here you see what the output of the date bucket function is. Date bucket is, let's say, rounding it up to the corresponding measure. So it's the 1st of January. So that means this date is from the result, from the date bucket, in this range here, in this month, 1st of January. And when we know this, then we can use something like this. Have a look to this query here. I want to have the city name, the aggregation. This is a cross supply where I give the month and the year. I run this query, see what happens. So I see now here the first, so from all the data it's running here, we see here the aggregation, number of measures, the average temperature, but all this output is okay. Have a look to this one. Oh, this is something what is weird. I don't understand. This should not be there. Why? That makes me curious because the date bucket should normally eliminate the hash aggregation. Why not? Go for this one. One moment. Aggregation, so date bucket of the year. Yes, see this. This was the former query. Now this is life. I go over all, and it's running, and it's running, and it's running. We break this and see what SQL Server is doing here. You do not see any hash aggregation anymore. So what is the reason behind? The time is part of the index, and the date bucket function is considering this. So there is no more internal transformation of it, which does not affect the index or will not use the index. And based on this, we have the good thing here that we do not have memory allocations anymore. So here we have the same with the pre-allocation. I go over all, that makes it a little bit difficult. So I go with the date bucket per year. So that means for every single city, we get the amount of data or the average over the year. But you see, I would prefer the old version. Here it's finished in 19 seconds. That was 4 times longer. But there is no more memory grants. But to be honest, then I would prefer to have the memory grants instead of this. Intervals can now be easily generated. You see this here when I say from to for Austin. And here you will see that goes very quick now. What is it? Date bucket minute? Yes, I want to have every 15 minutes, a bucket for every 15 minutes. And here we go. And that goes really incredibly fast. SQL Server is considering for the date bucket the index here. We do not have any aggregation here. That means that we do not have any stop operator at that time. And that does mean that there is no more memory consumption with these kind of queries. And that is a really great opportunity here to speed up the queries. For an overall, like I did before, I would say it depends. I would easily work with column store when it comes to, let's say, 15 years aggregation. That, to be honest, nobody is doing that. So, and we have a little bit more helpers here. 7 minutes to go. Generate series in conjunction with date bucket. That is a cool thing. See this. So here, I go into my demo database, and how many of you had on their wish list to generate very quickly a list of pure numbers? 1, 2, 3, 4, for aggregation, for anything like this, auto numbering, all this kind of stuff. I think what you all were using before, let me guess, is something like row number to generate rows. It's working, but it's not really the best. But what you can do is here, we have a new feature, generate series. It's very simple, very easy to use. Start value, end value, step. That's it. And see how it works? Here it is. First of all, very simple. Okay, nothing very highly sophisticated. You can do it with steps. Say here in the step is 5, so I go from 0 to 100, 0, 5, and so on. Easy. What you can do is, you cannot only generate integers, you can generate decimals, you can generate floats but integers, small ints, big ints. It all depends on the values you have here in your start and stop and the interval. And now see this query. Do you think that will work? The good thing, nobody here has a computer to test it. Make it short, it will not work. The reason is that the data types, you get a clash of data types because these are here, 0 and 100 are small integers, and we want to have a step which is a numeric value, a decimal. And this is an operand clash, so that will not work. If you want to do that, you must make sure that all of the data, the start, the end, and the step, are from the same data type. Then it works. 5 minutes left. Okay, yeah. So in combination with the generate series and the date bucket function, you now have a good opportunity to create very, very quick time series, which you can then join with your time series data. Here is the query. You see here that I generated series with 5 minutes. You see from the date bucket that I want to have 5-minute buckets. And what I'm doing then is here, I'm add the 5 minutes to the current date. So I go 15 minutes ahead. I can do it with the same way, vice versa, no problem. Run it. And then here I have immediately my 5-minute bucket list. And then you can do it or run this or use that in your queries. This is way, way faster, not so resource intensive like CTEs or something like that. So, make it short. Common table expression was the first choice when it came to creating date bucket. That was before SQL 22. With generate series, you have the opportunity to create numbered list, which can be used with the date bucket function, the start, the stop, and the step. You see here the start value. That's the same for the stop value. Tiny int, small int, big int, decimal or numeric. But keep in mind, when the step is a numeric value, then the start and the end must be from the same data type. Otherwise, it will not work. Date trunc is something, I didn't show it to you, but date trunc stands for truncate. What does this mean? Date trunc makes your time or your date time. Let me show this, very simple. I love this feature. I really love it. How often did I have the wish list to say, we are now at the 9th of May and I want to have the beginning of this month. How did you calculate it? You say, oh, take the actual date, make it a date, subtract the day from the current date, and then +1, and then you have the first off, blah, blah, blah. My goodness. That's so easy. Do it like this. When you use the truncate function, you can say, give me the year, the month, the day, the hour, the minute, the second, and so on, and see what happens here. So you see here, year, X, takes a year and appends the 1st of January. The month takes the year and the month and add the first day of the month. And so on and so on. So it truncates from the interval, the rest of it, and fills it up with zeros. Super, super cool. Really cool thing. And the date bucket, that is my favorite here. The date bucket function returns a date time corresponding to the start of each datetime bucket. So the date part is the most important here. This determines the interval of the buckets you want to create. Year, month, day, and so on and so on. The number that decides the width of the bucket. For example, if you say day and you put a 14, then it means make a bucket for every 14 days, and so on. And the date. That's it. So I'm finished now. Dziękuję bardzo for having me here in Wrocław. Ciao.